All right, hey everybody. So I have heard that we might be a little bit confused on the homework that I assigned on Monday, Tuesday. So here's the deal. This is a big part of your test. So I thought that it would be smarter to go ahead and go over this homework and then remind you that these notes, the rules of exponents, tell you what each property does and how they work. So those notes are going to be super helpful for you, but also I thought that it might be a little bit more helpful if we go back through this homework and talk through some things. So here we go. We are evaluating the expression. So all of these are numbers, and because it says the word evaluate, and this is my bad because I'm fairly certain somebody emailed me about this and I incorrectly answered, you are going to get down to one number. So here we have two bases multiplied, which means that we are going to add the powers. This is called the product of powers. So I've got 4 to the power of 6, which is equal to, if you take out your calculator, and I, of course, left my real calculator at school, so I'm going to be using this one. 4 to the power of 6 is 4 times 4 times 4 times 4 times 4 times 4. So I have 1, 2, 3, 4, 5, 6 fours all multiplied to get 4,096. Please ignore Winston whining in the background. All right. Now we have 5 to the power of negative 2 to the power of 3. This is what we called the power of a power. Because that power is on the outside, that is the power raised to that power. We have 5 to the power of negative 2, which we write as 1 over 5 to the power of 2. And we have that to the power of 3, which means we actually have 1 over 5 to the power of 6, because we multiply 2 times 3. Remember, a negative, all it does is change the placement. So if there's a negative on attached to a whole number like this, it's going to change it into a fraction. If this were a negative 2, it would change it to the whole number. It just flips it. Please forgive my pen running out of ink. Now we can actually figure out what this is, 5 to the power of 6. So again, you're going to take 5 times 5 times 5 times 5 times 5 times 5, and you're going to get 1 over 15,625. That is a very, very small fraction. Now, I would honestly also accept 4 to the power of 6 or 1 to the power of 5, 6, because that would be correct on your test as well. So if you didn't get it all the way down to one number, please don't worry. I will still accept it. All right, now we have 5 to the power of 2 over 5 to the power of 5. This is going to be the quotient, or power of a quotient. All right, so we're going to subtract top minus bottom, which gives us 2 minus 5, which is 5 to the power of negative 3. In other words, 1 over 5 to the power of 3. All right, again, we're going back to understanding those integer rules. So we could go ahead and get this down to one number, 5 times 5 times 5, which would be 1 over 125. All right, so if you're noticing, each time I'm working through and I'm figuring out, okay, I have power of a power. Power of a power. I have product of a power, quotient of a power. Down here, again, I'm going to have this power applies to everything inside. So it would be 3 to the power of 3 over 7 to the power of 3, which we can simplify. 3 times 3 is 9, times 3 is 27. Mrs. Quill cannot do this second one in her head. 7 times 7 times 7. would be 343. And that would be our new answer. All right, so each time I'm figuring out, okay, what is happening? What rule am I using? So what about when we go down here and I'm looking at something along the lines of 13, where I've got, oh, no, 13 has different bases. So we're just doing power of a power. I've got 3 times 2, so I've got, ooh, pause. Mrs. Coyle almost made a big mistake. This 2 applies to 4 and a. So I also need 4 to the power of 2, which is going to be 16 times a. 3 times 2 is 6. And then that 2 applies to 2. 2 to the power of 2 is 4. B. 4 times 2 is 8. And that would be my simplified answer. Because this 2 applies to every piece. All right. We actually talked about with the distributive property, how anything on the outside applies to everything on the inside. Well, this exponent is on the outside of our parentheses, so it has to be applied to each piece. All right. That's a big part of how we are working here. And please, please, please don't forget, exponents are different than just multiplying. We are multiplying that same number that many times. All right. All right, let's look and see if there's something else that I can show you. Aha, let's look at number 18, because I think number 18 is where we start to get a little confused. Because there's multiple pieces. Now, if I'm looking at number 18, I've got 5x to the power of 3 times y to the power of 9. But then down here, I've got 20x to the power of 2 and y to the power of negative 2. Again, all this is the rule of quotients. All right? So x to the power of 3 minus x to the power of 2. 3 minus 2 is 1, so we'll keep 5x on top. 9, ooh, this actually adds. So remember how I said it's 9 minus negative 2. So 9 minus negative 2 is actually 9 plus 2, 9, 10, 11. So it's y to the power of 11. That 20 has to stay on the bottom. We didn't get rid of the 20 just because it's on the bottom. All right. But can we simplify this further? Can I simplify 5 and 20? I can, in fact. If I divide 5 by 5 and 20 by 5, I can get 1x y11 over 5. Oh, sorry, 4. This is me to boo-boo. And actually, we don't even need that 1. It would just be x times y to the power of 11 divided by 4. All right, that's just simplifying our problem. All right. Again, look at 19. It's got a negative on the bottom, which means 5 minus negative 2 turns into 5 plus 2. We have x to the power of 7. Now, I can only do that because they have the same base. All right. When I'm working with different bases, I have to leave them alone, just like I did with 13, where they had different bases. So B had to stay on the bottom, A had to stay on the top. I can only do the subtraction of the rules of the power of a quotient when they have the same base. So if I look at 16, x to the power of 11, y to the power of 10, x to the power of negative 3, y to the power of negative 1. 11 plus 11 minus negative 3 is 11 plus 3. So I get x to the power of 14. 10 minus negative 1 would be y to the power of 11. And that's it. All right. I know that I said we're not going to be working a whole lot with negatives, but I do think it's important that we understand what they do, which is just change the placing. All right. In other words, if I thought about this the other way, I could have said, okay, I'm going to put y to the power of 1 on top. Y times y to the power of 1 would be y to the power of 11. X to the power of 11 times x to the power of 3 Add them together, x to the power of 14. I just think that it's easier sometimes to think about this as working with integers because that's something you already know and understand. Now, let's look at the very bottom because I think that's probably where we looked at and panicked. So if I'm looking at number 26, I've got x y to the power of 9 over 3y to the power of negative 2 times negative 7y over 21x to the power of 5. So I'm going to go all the way across. Because this is multiplying, we're doing the product of powers. In other words, I'm going to take x, there's nothing to add x to, so we've got negative 7, x, y to the power 9, and y by itself, which there's an invisible 1 there. So y to the power of 9 plus y to the power of 1 would be y to the power of 10. That's our top. And let's multiply the bottoms. 3y to the power of negative 2, 21x to the power of 5. So we need to multiply 3 times 21 is 63. Y to the power of negative 2, x to the power of 5, because there was nothing to work with there. All right. Now I can start working through the power of quotients. So I have x to the power of 1 up here, subtracting x to the power of 5. So in other words, I now have negative 7x to the power of negative 4, and then y to the power of 10 minus negative 2, which is y to the power of 12, all over 63. But, Mrs. Coyle, there's a negative 4 there. So that means that I need to simplify further. I get negative 7 y to the power of 12 over 63x to the power of negative 4. Not negative 4, sorry, it turns into positive 4. Oops. All right. Can I simplify this further? Can I simplify my fraction, or in other words, my numbers? 63 and 7. Is there anything we can divide 63 and 7 that is in common? I'm going to tell you right now, you can divide 63 by 7. So we end up with negative y to the power of 12 over 9x to the power of 4. So I know this is a lot of steps, but I believe you can do it. All right? Take your time. Make sure that you multiply across and then divide. In fact, we could probably divide and then multiply. It will do the same thing. It's just about making sure that we're following through each step. On the back, I believe one of the biggest problems was how they explained what to do. I want you to ignore what the heck this is saying. You're just going to solve exactly like we were doing. You're going to be following your rules of exponents. You're going to be following exactly what it's telling you to do. This side should be easier if you're looking at it that way. I want you, if nothing else, to take away from this that you should know the properties of exponents, the power of a power, power of products, power of a quotient, negative exponents, all of that. All right? And please remember, if something is a 0 exponent, the entire thing is 1. All right, bye guys.